Hi, I'm Bernadette Grantham,
And I'm Hector Rowland.
and this is our 2316 final project about stand your ground laws. So here's our table of context. We're going to start with the background.
Yeah, so first of all, this project focuses on the stand your ground laws, which are the statutes that allow individuals to use reasonable force, including deadly force, for self-defense purposes without a person needing to retreat, to retreat from a threat. We chose this because it is a largely debated topic, and there's lots of data available, such as population and crime rates.
So the purpose of this project was, depending on the outcome, it may influence whether fewer or more self-defense laws are passed. And we kind of expect that crime rates might decrease if offenders fear armed self-defense, but violence may also increase due to escalated confrontations. So for the data and collection and cleaning, our first source was for the crime statistics, and we found this from the FBI Crime Data Explorer. This gives us access to uniform crime reporting data, and it's important because it provides reliable nationwide crime data. This will allow us to analyze the crime by state and year, allowing comparison of crime rates before and after the Stand Your Ground laws. This will help identify trends and patterns in crime over time. For cleaning this data, we manually mapped the state abbreviations to the state full name, then extracted these state abbreviations. We then read the fixed with text files by slicing specific character positions, isolating numeric crime data from the designated columns, and then we split this data into consistent chunks for readability. We then converted these into integers and then summed the parse values to compute total crime record per record.
Now, in regards to population data, the source used for this was the U.S. Census Bureau, and this was a very important source as the U.S. Census Bureau posts the population data every single year, except for 2020, which is important when calculating crime rates as the population numbers are very important to know when calculating the crime rate of a state. So when cleaning this data set, first we checked if the API was responsive by checking the access code. After this, we removed the headers and sorted the data alphabetically to account for years sorted differently. All of this in a for loop that changes the specific year that the population data was collected. After this, we also changed all of the population number strings into integers so that they could be used later in calculation. And with this, we created a new set with just the states and population numbers, and then appended the specific year for each set. And finally, we created a data frame that combined every year of population data for each state.
Finally, for the Stand Your Ground Law state population set, we use the JAMA internal medicine, which just had a table of when each Stand Your Ground law was passed. This helped identify which states passed Stand Your Ground laws and provided the exact year the law was enacted, which allows for comparison before and after the law. So for this data cleaning, we loaded and parsed the HTML file using Beautiful Soup and then extracted the relevant text from the paragraph elements containing the Stand Your Ground law data. Then we used regex to identify and isolate the state names and years, and we just cleaned and stripped the text to remove extra spaces or formatting. We then converted these into integers and then stored the structure into a data frame with labeled columns and then sorted with by year. So for the data analysis, for Insight 1, we were mostly just going for being able to compare states without Stand Your Ground and before and after. So we merged all of the crime, population, and Stand Your Ground law data sets, and then we just calculate the crime rate, and then we had a before, after, no Stand Your Ground rate, no Stand Your Ground law column, and then we just calculate the change to see whether crime rate increased or decreased after it was passed. This was important because Stand Your Ground laws do not show a consistent impact on crime rates alone. Some states saw increases and others saw decreases or no change. There is no clear evidence that Stand Your Ground laws reduce crime rate overall with just this one insight.
Now for Insight 2, We first of all used the merged data from Insight 1 and removed all of the missing values. After this, we selected the population as the predictor and crime rate as response. After splitting the data into training and testing sets, we used a pipeline, i.e. a scaling and linear regression model, and trained the model on training data. This helped predict crime rates on test data, and it gave us an R2 score. The takeaway from this was that there was a very weak relationship between population and crime rate. In other words, as the population grows, that did not necessarily mean that the crime rate would grow. And therefore, the population only explains a small portion of crime variation.
So for Insight 3 and 4, we focused on clustering the data. So for this, we merged the data set and calculated the average crime rate by state. We applied k-means clustering. We split into 3 groups, a high crime, a low crime, and a medium crime, and then stored and analyzed the clusters by average crime rate. This helps us compare states with similar baseline crime levels and improves accuracy when analyzing the stand your ground law impact. In Insight 4, we took what we had split the groups into for Insight 3, and then we kind of tried to see what percentage of each cluster has a stand your ground law and which does not have a stand your ground law. We saw that higher crime clusters actually have a greater percentage of stand your ground law states, and lower crime clusters have fewer stand your ground law states. This suggests that stand your ground laws are more common in higher crime rate states. It indicates a relationship, but not necessarily a causation between stand your ground laws and crime levels.
Now for Insight 5, we wanted to see if the stand your ground law states and the non-stand your ground law states had more or less crime than the other one, just in a very obvious table. So we created the stand your ground law status based on year, grouped the data by year and status to observe overall trends. And after observing that, oddly enough, the stand your ground law states had a higher average crime rate than non-stand your ground law states, we created a relative timeline, making year 0 the year the law was passed for each different grouping. So say all the states that passed the law in 1994, all the states that passed in 2005, different groups, and with year 0 being the year the law was adopted, every year before that showed the average crime for that cluster of states, and every year after that also showed the average crime rate for that cluster of states. And so after grouping the data by years before and after adoption, we compared crime trends relative to the stand your ground law integration. So the initial trend showed that the takeaway from this is that it showed that the initial trend was that the crime was increasing after the stand your ground laws, but this was actually a misleading trend due to something called the Simpson's paradox. So when analyzing by adoption timing, the crime actually decreased after the laws in that specific cluster of states. So this proved that later adopting states actually had higher crime rates beforehand, and those higher crime rates were the reason why the initial findings were that the stand your ground laws were leading to higher crime rates than no stand your ground laws. So this showed the importance of grouping data correctly before drawing conclusions.
So for our first visualization, we were able to compare the states who had already passed a stand your ground law and compare the change in crime rate before and after. We see that West Virginia had a huge drop in how much crime they had before and after they passed their stand your ground law, versus all the states that did increase had very little increase, if at all. For visualization 2, we saw that states that already had higher crime rates were more likely after passing a stand your ground law to drop further than states with lower crime rates, which had very minimal change.
And then visualization 3 showed the average homicide rate trends for stand your ground law states and non-stand your ground law states, and it did show, this is the very general trend, that stand your ground law states actually had higher homicide rate trends than non-stand your ground law states.
And then for our conclusion, the initial results suggested that crime increased after the Stand Your Ground laws were passed, but this was actually misleading, and we saw that through Simpson's paradox. When the states were grouped correctly, different patterns emerged across the states. So things we learned were a lot of different methods to use, and we would say that our greatest challenge was parsing complex fixed width UCR data, which was unreadable without cleaning and new to us.